A service level agreement, or an SLA, is a contract between a provider of a service and a consumer of that said service. In this case, the provider is Microsoft Azure in the public cloud, and we are the cloud consumers. Now, service level agreements are important because they guarantee uptime for a service. Now, what does that have to do with security? Plenty, because one big aspect of security is availability, making sure that services and data are available when they are needed. So, as a security expert, it's important to take a look at SLAs related to cloud computing services that your organization. So I used a web browser search engine to search for Microsoft Azure SLA, and that takes me here to this service level agreement page for the Azure cloud. Now, as I scroll down below, the first thing I noticed is that there is an SLA for each and every service offering available in the Azure cloud. And there's so many service offerings that they are categorized on the left. So for example, if I click on media, then on the right, I have a couple of listings, media services, content delivery network, where I could view the SLA for each of those items. If I were to click databases on the left, on the right, I have a number of different database service offerings, again, each of which has its own SLA. If I click containers, we get things like Azure Kubernetes service for container clusters and so on. If I click compute, we get all kinds of other services, each having their own SLA. So now that we're looking at compute, why don't we take a quick peek at the virtual machines service level agreement. So I'm going to go ahead and click to open that up. An important aspect of an SLA, especially in the cloud, is that you read through it carefully because some of the guaranteed uptime statements might depend on a specific configuration of that service. So in the first example, it's talking about virtual machines where you have two or more virtual machine instances deployed across two or more availability zones, then you get an uptime guarantee of 99.99%. But that's only if you have that type of configuration. Then there are listings here for single instance virtual machines using premium SSD disks and so on, and their guaranteed uptime statements. So it's important to take note of these to see how it fits with your use of those cloud services. And now I can open up the introduction section of this service level agreement, under which I then get a list of general terms. So think of this as a definition of the terms used throughout this document. Things like downtime, error code, external connectivity, incident, and so on. So it's a standard legal document in that sense. And then down below, we have information about how to submit a claim for service uptime that was not met, and about service credits and how they will apply. So we have a lot of these details that list here. There's also, of course, limitations where the service level agreement would not cover you in terms of missed uptime that was guaranteed and the acquisition of service credits. It wouldn't apply if there was something that was out of the control of the cloud service provider. Things like natural disasters, war, acts of terrorism, riots, government action, and so on. So those items would not count to getting service credits. Now that's an example of a virtual machine service level agreement. Why don't we go back in our browser and take a look at something related, for instance, to storage. So maybe I'll click storage on the left, and over on the right, maybe I'm interested in a storage account SLA. So I'll click on a storage account, and we'll wait for that to pop up. So we have the same type of document layout where we have some configurations specific to that service, such as read access geo-redundant storage versus local storage that is not replicated to other regions, and the uptime guarantees related to those. As I scroll further down, I then get, as we did before with the virtual machine SLA, an introduction. Under that, I then have a definition of terms, otherwise labeled here as general terms for this particular SLA. And notice the terms will vary from one SLA to another because they refer to different cloud services. And then we have information about how claims are made and the service credits that would apply. And then, of course, any limitations, that type of thing. At the bottom of each SLA, you will have a revision history. So you'll see the versions of the SLAs at different points in time. They're hyperlinked, and you'll see the date stamps with them. The use of cloud computing implies the level of trust from the perspective of the cloud customer. They trust that the cloud service provider has done their due diligence in hiring personnel to man their data centers, and that the underlying equipment is configured securely in accordance with industry security standards, and perhaps data privacy regulations. But hoping isn't enough. How do we verify that that is true for a given cloud provider? Well, the first way that we can answer that is by looking at the Cloud Controls Matrix, or the CCM. This is available on the cloudsecurityalliance.org website. Cloud Security Alliance you'll often see abbreviated just as CSA. So I've navigated to the Cloud Controls Matrix on the CSA site, and I'm going to go ahead and click the Download the CCM button. That's going to take you to another page that talks about the Cloud Controls Matrix. In this case, happens to be version 4. So down below, I have to specify a few details like the job that I currently work in and so on. So I'm just going to go ahead and get through that. And then I'll click Download. It's an Excel spreadsheet, so I'm just going to go ahead and click Open down in the bottom left in my browser. So here in this Excel spreadsheet, we now have a number of different control domains over on the left, like audit and assurance. And as I go down through this spreadsheet, we've got business continuity management, and this is all related to the cloud, change control and configuration management. And interestingly, we can also search. So for example, let's say I search for the word encryption, and I'll go ahead and press enter. And already it's found that section here in the Cloud Controls Matrix, the section on cryptography, encryption, and key management. So what's interesting is as I scroll over to the right in the spreadsheet, I have a responsibility and ownership item here for infrastructure as a service, platform as a service, and software as a service. Shared means that the cloud provider and the cloud tenant both have some responsibility. And as we go further to the right through here, we'll get some information as to whether it relates to HR, supply chain management, if there are legal and privacy implications, operations, software development, and so on. So of course, cryptography is wide-reaching in its scope, so it shows up for all of those items. Down at the bottom, I can also go to the Scope, Applicability, or Mappings worksheet. And from here, I'll see the same type of information, but as I go over to the right, I will start to see the control mapping. And a lot of these are referring to things like ISO standards and so on. So ISO/IEC 27001 really deals a lot with information security management. So we can start reading about this and download the publication so that we can learn more about the individual security controls that are referenced in the Cloud Controls Matrix. Now, I'm still on the cloudsecurityalliance.org site, but I'm looking at the Security, Trust, Assurance, and Risk, or STAR, registry. Now, this is a way that cloud providers can be audited, either self-audited, third-party audited, so that they can acquire certifications and be registered here so that customers or even potential customers can verify which security standards cloud providers are compliant with. So as I scroll down here, I can read about the STAR program, where STAR Level 1 would be a continuous self-assessment, but if we take a look at STAR Level 2, it's a third-party certification that the cloud provider is compliant with certain security standards. Now, the great thing about this is I can search the STAR registry. So if I click the registry link on that page, we'll then get an alphabetical listing of cloud providers that have registered with the STAR registry. So from here, I could search or I could manually scroll through. So for example, let's say I search for Amazon. So I've typed in Amazon as my search term, and I'll just go ahead and press enter. Then I'll scroll down and there's Amazon. So I'm going to go ahead and click on the link for Amazon so that we can read about their STAR registry certification. So I have a sense here of what happened and when it happened, such as an assessment that was provided in this case on August 5th, 2020, and also more recently, November 7th, 2020. So STAR Certification V1, and this is the Consensus Assessment Initiative Questionnaire. I could download and read that. So let's go ahead and start with that. I'm going to click on the download link. So when I go through this PDF document, it talks about how Amazon Web Services, or AWS, is compliant in terms of how they run their cloud services. Now, I'm not going to read all of that detail. However, let's go back and let's download the STAR certification document. So I'm going to click download to open that item. And then I'm going to go to that location and I'm just going to make sure that I extract it. Now, what we want to do here is open up the PDF. When I open that PDF, it is a star certificate registry entry, in this case specifically for Amazon Web Services, Inc. There's a little description about them, the scope to which this applies, the number of sites they have, the cloud controls matrix or CCM version used, in this case 3.01. We just looked at version 4, so it's a newer update compared to that. Let's close that out and let's download the supporting asset for star certification. And again, this is going to be another zip file that I'm going to download and I'm going to extract. And when I open that PDF, after having extracted it, I have the CSA Star Certification certificate that was awarded to Amazon Web Services. I have the issue date for the certificate and when it expires. And down below, we have a listing for the scope of what it applies to. And further down in this document, we see the locations where they have data centers that this applies to. Now, what we're really looking at here is that this complies with CSA, or Cloud Security Alliance, Star CCM version 3.01, Cloud Controls Matrix. So that's what this specific certificate that was awarded to Amazon describes. In the cloud, a VNet is a virtual network, and you need to take the same care in setting it up and securing it that you would with a regular network on premises. That means, first of all, defining the purpose of the network. Why do you need it? And are you going to have one or more subnets? And what are the IP addresses going to be that you're going to assign to those subnets? And do you want to limit traffic into or out of those subnets? All of that same type of stuff, all those same considerations apply in the cloud as they do on premises. So here in Microsoft Azure, I'm going to create a virtual network. So to get started with that, I'm going to click Create a Resource in the upper left. And then I'll type in Virtual Network in the field, the search field, and then I'll choose Virtual Network from the resultant list. And then finally, I'll choose Create. So we would have done our pre-planning ahead of this, so we'll know how to fill in all of these fields. So I have to tie this virtual network to one of my Microsoft Azure subscriptions, so that's fine. I can then either create a new resource group or select one from the list, which I'll do. A resource group, like the name implies, is a way for you to organize related cloud resources like virtual machines, storage accounts, web apps, virtual networks, for any relationship at all. So if maybe you need a number of those items to support a single app, you might organize them all into a resource group so they can be managed as a unit. So I'm going to call this one VNet1. I can determine the geographical region where that will be created. In this case, I'll leave it on Canada East, and I'll click Next IP addresses at the bottom. Now, it has suggested the 10.0.0.0/16 network range, so 16 bits in the subnet mask. So really, the network here is 10.0. I could either remove that by clicking the trash can over on the right, or I could keep it, and I could even add additional network ranges. I'm going to go ahead and stick with the default range that it has assigned. I'm okay with that. I could also add an IPv6 address space if I need to support that. I don't. Down below, it's created a default subnet that's using the 10.0.0.0/24 subnet. So in other words, the first 3 octets, in other words 24 bits, identify the network. However, I can accept that or I can change it. I can remove the subnet. If I were to select it, I could choose to remove it, which I will. And I can click Add Subnet, so I have a little bit more control of how it's added. I want this to be called Subnet 1, and maybe what I want to do is I want to use the 10.0. Now that's my VNet prefix, 16 bits. I can't change that. But then I'm going to use .1.0/24. That's what I'm going to use for my IP address range. And I'll click Add. I'll click Next Security at the bottom. Here I can enable some security mechanisms, and this is important. For example, a Bastion host is a jump box. I can enable this so that in order to come in from the internet to manage virtual machines in this VNet, normally they would need a public IP address, which is a security risk. Instead, they would only have private IPs, and I could use the Bastion host configuration to connect to them to remotely manage them, whether they're Linux or Windows based. So that means we don't need a public IP for those internal hosts. So we can enable that at this point or at any time thereafter. We can also enable DDoS protection, distributed denial of service. And we can also enable Azure Firewall. Again, all of these can be configured after the fact. So I'm going to leave them disabled for now, and I'm going to click Next. We can add tags. Tags are metadata. They're additional properties or attributes. For example, I might want to tie this to a project. So maybe I'll create a tag name called project with the value of ABC. So I could tag resources that way, and I could search for them later and group them together, or even view costs associated with project ABC. I'm going to go ahead and click Next, Review and Create. And once it's run the final validation based on my selections, I can go ahead and click Create in the bottom left to actually create our VNet, VNet1. And before you know it, it's done. So it says your deployment is complete. So I'm going to click Go to Resource to open it up. That takes me into the properties of my VNet, where I have an extensive navigation bar on the left that I can scroll up and down through. We're currently looking at the overview page. So on the right, my address space is shown based on our selection. And if I click subnets on the left, then on the right, it'll show me subnet 1 that we created with the configured IPv4 address range. Now I could go back to address space on the left. This will show me the address space for the VNet, what we started off with, but I could add additional IP address ranges. I could also add additional subnets. For example, if I go back into subnets on the left, on the right, I'm going to click the Add Subnet button. I'm going to call this Subnet 2. You could use better, more meaningful names than this, but I'm going to use the 10.0.2.0/24 network range. That tells me the first 3 octets, in this case 10.0.2, identify the network, where for subnet 1, 10.0.1 identifies that. And again, we have the option to add an IPv6 address space. We can use a NAT gateway to get out to the internet. A network security group, we'll be doing some of these things later, which can allow or deny traffic. It's like a packet filtering firewall. We could also associate this subnet with a route table if we want to control routing in a particular way, maybe to send outbound traffic to the internet first through a firewall appliance for inspection. So I'm just going to go ahead and click Save. So we will have created now 2 subnets within this VNet. On the left, if I were to click Connected Devices, we're not going to see anything yet, but once we start deploying things like virtual machines and so on, this screen of connected devices for this VNet will begin to become populated. So now in Azure, I can open up my navigation bar in the very upper left, and from here, I could go to my virtual networks view to view all of my virtual networks in one place. And sure enough, this is where we'll see VNet1. In this demonstration, I'm going to create a network security group. In Microsoft Azure, a network security group is like a packet filtering firewall configuration where we can create multiple rules to allow or deny traffic based on what appears in packet headers, things like IP addresses for source and destination, port numbers for source and destination, protocol type, that type of thing. So to get started, I'm going in the portal here to click Create a Resource in the upper left, and I'm going to type in Network Security Group. Of course, I could click on the categories down below to select it from there, but I'm going to go ahead and just type it in. It's quicker for me. And then I'll go ahead and click on Create. So I'm going to tie this to my pay-as-you-go subscription. I'm going to put this in an existing resource group called Testing, and I'm going to call this Windows Standard. This is going to be for Windows traffic. Essentially, I want to make sure I allow things like RDP, Remote Desktop Protocol, and HTTPS into the subnet. So that's going to be in the Canada East region. I'll click Next for tags, and if this is related, let's say, to a project, I could specify the project I want to associate it with. Now, project ABC shows up in these fields because I've already tagged a resource with those items. Otherwise, it wouldn't have popped up. So I'm going to click Next, Review and Create, and it's going to check my selections before it gives me the validation I need to proceed. So I'm going to go ahead and click Create in the bottom left to create this network security group. And before you know it, it's complete. So I'm going to go ahead and click Go to Resource to open up our Windows Standard Network Security Group. That takes us into the properties of it, where on the left, we're in the Overview blade. So on the right, I don't have any inbound or outbound rules. If I click Inbound Rules over on the left, I've got the default rules within this security group, and I can hide the default rules. They're still going to be in effect, but I can just remove them from the screen by clicking that. I can click the Show Default Rules button to get them back. So the first thing is to allow traffic inbound from any other VNets. So that action is set to allow. The next rule is to allow traffic from an Azure load balancer. That again has an action of allow. And finally, everything else is denied. We're denying all other inbound traffic. It's set to deny. So this means if we had virtual machines that we needed to get to that were running Windows and we want to RDP them, we wouldn't be able to get through this network security group to RDP them. So what I'm going to do is add a rule. I'm going to click Add up at the top, and this is going to be for Remote Desktop Protocol. So the source can be from any location or an IP address or a certain tag value or an application security group. I want to allow from anywhere. The source port range I'll leave as an asterisk, so any port number, but the destination, this is where I can specify an IP address. If I know that I've got a fixed IP address for a virtual machine, then I can go ahead and plug that in. For the service, I'm going to go through the list here and choose RDP, which uses port 3389 over TCP. That's already selected and grayed out. And I can either allow or deny it. Well, I want to allow it. But the priority number here is important. Notice the priority numbers in the background are 65,000, 65,001, and 65,500. This means that rule 65,000 gets checked against incoming traffic because these are inbound rules. It gets checked before the other two rules because of its numeric value. So if I create my RDP rule with a priority of 100, it's going to be checked first. And if there's a match, then the traffic's either allowed or denied, and no further rule checking is done. So for the name, I'm going to call this Allow RDP. I'm going to go ahead and click Add to add that new rule. So I have a message in the upper right that it created the rule. I can click the refresh button to make sure I'm looking at the latest info. And here I've got my new rule with a priority of 100. I have a little alert symbol because we are allowing access from any when it comes to this. That's what the source is showing here under the source column. It's from any location. But I'm okay with that. Now, in the same way, we could also go to outbound security rules on the left. We have some default security rules to allow VNet traffic out. So by default, any traffic within a VNet is allowed out to the internet. Also, we're then denying all outbound if it doesn't match VNet or internet outbound. We can hide the default rules and show them just like with the inbound rules, but there's really no need to make a change here unless I had something I wanted to allow or deny in an outbound direction. Now, the other thing we have to do is associate this network security group with something, because right now it won't do anything anywhere. We can associate this with either a specific network interface for a virtual machine. We could associate them with a couple of them. So we would then be applying the rules in this network security group to specific virtual machines. Or instead of that, what we could do is associate it with an entire subnet. So all of the virtual machines within the subnet would be affected by the rules in the network security group. So that's what I want to do. So I've clicked subnets. Over on the right, I'm going to click the associate button at the top so I can select the subnet I want to associate this with. Now, subnets exist within virtual networks. So I first have to choose a virtual network. I'll choose that from the list. And then after that, I can select the appropriate subnet within that VNet, and I can choose OK. Now, this takes effect pretty much immediately once it's saved the subnet association. So at this point, we've now got subnet 1 that will allow inbound RDP traffic from anywhere to a specific IP address that we have designated for a virtual machine in our subnet. In this demonstration, I'll be deploying a Windows virtual machine into the Microsoft Azure cloud. Now remember, one of the great things about cloud computing is that we have self-provisioning. In other words, in this case, myself as the cloud customer, I get to provision virtual machines as I see fit. And I can do that programmatically or using command line tools. I could also do it using a GUI, which I'm going to do here. The Microsoft Azure GUI, the web page, is called the Azure portal, which is where I am now. So I'm going to create a new virtual machine. For that, in the portal, I'll click on Create a Resource in the upper left. Now over on the right, under Popular, I can select Windows Server 2016 Data Center. I'm going to go ahead and do that, but once I'm in the next screen, I can also make a change to the operating system image if I so choose. So I need to tie this virtual machine to an Azure subscription and put it in a resource group. I'm going to call this WinServe1. And down below, Canada East is the region where the virtual machine will be deployed. That's fine, since that's where most technicians that will be accessing it reside. We can also, down below, change the virtual machine size. This is the underlying horsepower. In this case, we've got one virtual CPU and 3.5 gigs of memory, but we could change this at any point and time. Now, I can also specify, as we've mentioned, a different version of the operating system. For example, Windows Server 2019. And then I'm going to specify a username and a password. So I want to make sure I use a difficult, complex password in accordance with organizational password policies. And then moving on down below, I can specify if I want any public inbound ports. By default, it's elected to open up RDP port 3389. So that's fine. We can do that. I'm going to go ahead and click Next for disks and specify whether we want to add additional data disks. I don't. So I'll click Next for networking. Next thing I have to do is deploy this into a network like I would on premises. So for here, I'm going to leave it on VNet 1. That's my virtual network. And subnet 1. I can choose the subnet from the subnet list. It wants to assign a public IP address. Now, for testing purposes, assigning a public IP, so it's publicly visible for a VM, is okay, but only for testing. For production, this is never acceptable. It should only have a private IP address in the cloud, and you can get to it and manage it over the internet through a jump box, or in the case of Microsoft Azure, a Bastion host configuration. Because this is just for testing purposes, I will let it assign a public IP. And I'm going to click Next for management. I'm not going to make any changes actually on the next couple of pages, so I'm just going to go ahead and choose Review and Create. It's going to check my selections, after which I'll then be able to actually deploy this Windows virtual machine. So the validation has passed, therefore I will click the Create button in the bottom left. And before too long, the deployment is complete. So I'll just click Go to Resource so we can open up the property sheet for that deployed virtual machine. So in the overview page on the left, we see the details for that page on the right, such as the public IP address that was assigned and the virtual network and subnet affiliation for this particular virtual machine. If I click on networking down over on the left in the navigation bar, not only does this virtual machine have a public IP, which we said is acceptable only because this is a testing VM, but it also has a private IP that was assigned automatically based on the IP address range we associated with the subnet where this VM was deployed. Now we can also specify which network security group that we want to use for in and outbound rules. If I look at the inbound port rules that are applicable to this particular virtual machine, there's a rule with a priority of 100. It's called Allow RDP. Looks like the source is from anywhere, and the destination is to this particular IP, 10.0.1.10. Well, I'm going to go ahead and make a change here because I want to make sure RDP is allowed to any servers within this network. So to make that change, I have to go into my network security group, and I've got a link for it right here. It's called Windows Standard. That switches me to the property sheet for it, where I'll click Inbound Security Rules over on the left. There's the Allow RDP rule. So I'm going to go ahead and click on the Allow RDP rule to open it up so I can make changes. Instead of the destination being IP addresses, I'm going to choose any. Now you have to make sure that this is only used for testing purposes, the virtual machines in the subnet. They are, so that's okay. I'm going to go ahead and click Save to save that rule. Okay, so if I were to go in the left-hand navigator in the upper left, I could open up the virtual machines view. This gives me one place where I can view only virtual machines. So we've got WinServe1, and currently the status is such that it is running. So when we go into it, remember, in the overview blade, we'll have the public IP address available. So I'm going to go ahead and copy that. There's a little copy to clipboard button to the right of the IP. And I'm going to open up my local RDP client on my Windows station. I'm going to go ahead and paste the public IP address into the computer field in the remote desktop connection client, and I'll click Connect. Then I'll specify the username and password that I configured when I deployed that virtual machine, and I'll click OK. Because it's the first time I've connected, it's going to ask me if I trust the certificate that's going to be used to secure the connection. So I'm going to tell it, don't ask me again, and yes, I trust it. And then after a moment, I'm in. I am remotely managing a cloud-based virtual machine over the internet. Now, there are a lot of brute force attacks that will sometimes succeed when you have public-facing RDP hosts, so I would never recommend this, other than perhaps for experimenting or testing. Now, the other interesting thing here is that if I were to go into a command prompt on my server, and if I were to type ipconfig to view the IP configuration, all I'm going to have here is the private IP. So the public IP address does not show up within the virtual machine OS. That's because the public IP address is a cloud configuration only. Now, from a security perspective, we also want to make sure we don't leave virtual machines running if they don't need to be running. All you're doing is increasing the attack surface, and that's very easy to do in the cloud. You can end up with what's called cloud VM sprawl, because it's so easy to deploy VMs. So, of course, we could manually shut down or stop the VM here by clicking the stop button, but also bear in mind that most cloud providers will have some kind of auto shutdown facility where you can schedule VMs to shut down if they aren't mission critical and don't need to be running 24/7. You can quickly and easily deploy virtual machines in the cloud, much like you would do on premises if you already have virtual machine templates, or if you're using operating system images that might be pre-hardened. In this case, we're going to deploy a Linux virtual machine in the Microsoft Azure public cloud. So to get started here in the Azure portal, in the upper left, I'm going to click Create a Resource. Now I can go through these categories on the left, or I can just select what I see under Popular on the right, such as Ubuntu Server 18.04 LTS. So I'm going to go ahead and click on that. Now, once I go into the wizard for deploying a virtual machine, I can then specify a different OS image if I choose. So I'm going to tie this to a subscription. I'm going to deploy it within an existing resource group, and I'm going to call this Ubuntu Serve 1. So make sure that you follow organizational naming conventions when it comes to naming these things. Because one part of securely managing an environment is to make sure that you can easily manage the items. And if you have a standard naming convention, it's easy to identify what type of servers we have, what they're used for, and so on. So I'll deploy this in the Canada East region, and this is where I can go to the image drop-down list, and I can select a different image. Now, I also have the option of using a custom image, which we'll get into in a minute. So for now, I'll just leave it on Ubuntu Server 18.04. The sizing controls the horsepower, so the CPUs and the amount of RAM, I'll leave that. And I can opt for either public key authentication or password authentication to Linux. Now, password authentication is just username and password. But with public key authentication, we have to have a username, and you must also possess a private key. Now, the public key is stored with the Linux server. You need the mathematically related private key. So that means we have to have something we know, which is the username, and something we have, which is the private key. So I'm going to leave it on SSH public key authentication. The username here will be Azure user. I could change that. And I can opt to generate a new public and private key pair or use an existing one. Now, I'm just going to generate a new one. And I'm going to leave that as it is. Scroll down. I'm going to leave the inbound port open for SSH, TCP port 22 for administration. Now, again, this is only a testing virtual machine, so making it publicly visible is okay, but for production, it never is. Instead, maybe we would require a VPN connection before allowing remote access to only the private IP of the Linux host, or maybe administration only through a Bastion host, a jump box. So for this, I'll leave it on allow selected ports. I could add tags, which I won't. I'll just go to review and create. It'll check the validation of my selections, and after that has passed, I'll be able to deploy the virtual machine. So when I create the virtual machine for generating the key pair, it prompts me to download the private key and then to continue creating the resource being the virtual machine. So I'm going to go ahead and click on the download button. In the bottom left of my web browser, I'm then prompted to save my key. So I'm going to go ahead and do that by clicking Save As, and I'll save it in my local downloads folder. So once the deployment is complete, I will click Go to Resource just so we can check out the property sheet for our newly deployed Linux virtual machine. So in the overview page over on the right, we have the sizing information for the VM. We have the public IP address, which I will copy. I know I'm going to need that. We see the network affiliation where this virtual machine was deployed, and so on. Up at the top, I also have a capture button. If we've deployed a virtual machine in the cloud and perhaps tweaked and configured the OS and hardened it and applied updates, maybe added software, we can then click the capture button to capture that as a custom image, from which we can then create other virtual machines in the cloud. Now, the benefit here, of course, is that it's customized and it can be hardened to your organization's security standards. However, I'm just going to click the X in the upper right. I don't want to capture that. So the next thing that I want to do is make a remote connection from my on-premises network into the Azure cloud using the PuTTY tool. PuTTY is normally used to make an SSH connection to hosts that have an SSH daemon running, like Linux. Now, I've launched the free PuTTY key generator tool, often just called PuTTYgen. You can download PuTTY and PuTTY keygen for free anywhere from the internet. Now, the reason I'm doing this is because the format that the private key file is in, as provided by Azure, is not consumable by the PuTTY remote management tool. And so I'm going to open it up in here and save it to a version that is consumable by PuTTY. So I don't want to generate a key pair or anything. I already have that done. I'm going to click the load button to load an existing private key file. So here I've opened up the private key file that was generated by Azure. Now what I want to do is put in a passphrase, because it is a private key file, I want to protect it, and then I'm going to go ahead and click the Save Private Key afterwards. And I'm going to save it as a file called Azure Ubuntu Linux, and I'll click Save. So there we go. We've now got our private key for public key authentication to Linux that's been saved in a format consumable by PuTTY. So let's fire up the PuTTY tool to make the SSH connection to the public IP of the Linux VM. So here in the PuTTY tool, I've pasted in the public IP and I've saved the settings here as Azure Ubuntu Linux. So in the future, I can just select it and load it up and everything's filled in. However, over on the left under Connection SSH, and under Auth for authentication, I'm going to specify the private key file that we've just saved into the correct format. I'm going to specify that here. Now that is a PPK file. There it is, Azure Ubuntu Linux. So once we've done that, I'm just going to go back here and save that, of course, and we're going to click Open to actually open the connection to that host. So I'm going to be prompted as to whether I trust that remote host. I do, so I'm going to choose Yes to add the unique fingerprint for this host to the registry on this machine. After which, I'm going to be prompted to log in. So the default username in our case is Azure User, but instead of asking for a password for that account, it's going to ask for the passphrase for the private key file that we have stored locally. So I'm going to go ahead and enter that and press Enter. After a moment, we are successfully logged in. So if I clear the screen with the clear command and issue commands such as who am I, it'll show me who I'm logged in as, which of course is going to be Azure User. If I type ifconfig, it'll show me some IP configuration information. And just like is the case with Windows, all we're going to see here is the private IP address. The public IP address does not show within the OS, although it is being used for it. It's just in Azure, the public IP address is a separate cloud resource external to the operating system. But because this is a testing virtual machine, having it publicly visible is okay, temporarily. But for production, it never is. So there you have it. That's how easy it is to get a Linux virtual machine deployed into the cloud and how to securely connect to it for remote management. In the cloud, after you've defined virtual networks, you can peer them together. Now, peering a VNet together, remember, provides the benefit of allowing virtual machines in one VNet to communicate directly with virtual machines in the peered VNet using public IP addresses. Because without peering, you need to communicate using public IPs, which goes over the internet. So this way, you use private IPs and the traffic stays on the cloud provider backbone global network. So to get started here, in the Microsoft Azure portal, I'm going to open up in the upper left my navigation bar, and I want to go all the way down and click on Virtual Networks because I want to view virtual networks that I have. So I've got a virtual network for my Ubuntu Linux virtual machine, and I've also got one called VNet1. I want to peer both of those VNets together. Now, before we go into that, let's go into our virtual machines view and check out what we've got. So when I go into my virtual machines, I'm going to have a Windows and a Linux VM. So if I open up the Ubuntu server Linux virtual machine, we see that the virtual network and subnet indeed is such that it is deployed into its own VNet. At the same time, if I go back to my virtual machines and open up the Windows virtual machine details, we'll see that it is deployed into VNet 1, subnet 1, so a different VNet and subnet. Now, why don't we fire up both of those VMs? I'm going to start the Windows VM by clicking the Start button here from the Overview page, and I'll do the exact same thing for Linux. Because what we're going to be doing before we peer those VNets together is we're going to test whether or not they can communicate with each other using their private IP addresses. Now, the expected result is that no, they cannot, because they aren't peered together yet. After we peer the VNets together, they will be able to communicate using private IPs. But let's prove that. So we'll just wait a moment while the VMs fire up. Okay, so maybe what I'll do is I'll go to the Windows virtual machine and I'll take a look at its private IP address. So I can do that, for example, by going into the networking page over on the left, because I want to be able to ping this from the perspective of my Linux virtual machine. So the private IP here is 10.0.1.4. Now, if we go and take a look at the private IP address of the Ubuntu virtual machine, it's going to be different, of course. Now, it's going to be on a different subnet, we should say. So it's on a different subnet, and if we take a look at the networking section, its private IP is 10.1.1.4. Okay, let's test this out. I'm going to remote into the Ubuntu Linux virtual machine, and we're going to test pinging the Windows virtual machine private IP, and it should fail. Let's see if that's true. So I'm going to use PuTTY here on my on-premises station to connect to the public IP of the Azure Ubuntu Linux virtual machine. So let's just open up that connection. Okay, so here in Linux, if I do an ifconfig, let's check out our private IP, 10.1.1.4. So let's go ahead and let's try to ping 10.0.1.4, which is the private IP address of our Windows virtual machine. Now, of course, we're not going to get a response because how will it get a route to that other private subnet? It's not going to be able to connect to it. So the only way they would be able to communicate is over the internet using public IPs. And that can present a security risk. Anytime you're communicating over a public network, there is more implied risk than when you're communicating on a private controlled network. So we're proving here it's not connectable via its private IP. So I'll just press Control-C to stop that. Okay, so back here in the Azure portal, let's go back into our virtual networks view and let's finally set up the peering. You can set up the peering from either VNet's perspective. It really doesn't matter. So I'll click on VNet 1, and over on the left, I'll scroll down in the navigation bar and I'll select peerings. Now, any existing peered VNets will be shown here. There are none, so I'm going to click the Add button up at the top to add a peering connection. The first thing I'll have to do is give this a peering link name. How about I call it WinVNet to Linux VNet? And we have some options. Do we want to allow or block the traffic? Do we want to allow traffic that's forwarded from a remote virtual network that doesn't initiate from that network? And all of those types of options. However, I'm just going to go down and add a peering link name to create a peering connection in the opposite direction. So maybe Linux VNet to Windows VNet. So it's setting up both ends of the peering connection. I have to choose the target VNet. It already knows we're setting this up within VNet 1, so I'm going to choose the Ubuntu Serve 1 VNet, and I'll leave all of the options to allow the connectivity, and I will click Add. So notice I've got two little notifications up here because it's setting up the connection in both directions. And that's why I said it doesn't matter which VNet you do this from. So after a moment, we have the peered VNet status showing as connected. So let's go back to Ubuntu Linux and see whether or not it can now ping the private IP of the Windows VM in a different VNet through the peering connection. Okay, so back here in Ubuntu Linux, I'm just going to use my up arrow key to go back to the ping command, and I'll press enter. Notice now we get a response immediately because we have these two VNets paired together. And so as a result, the VMs are able to communicate using only private IP addresses. One of the great things about cloud computing and security is the ease with which we can deploy secure solutions like firewall appliances. I'm going to configure Azure Firewall. So here in the Azure portal, I'm going to start by clicking Create a Resource in the upper left, and then I'm going to search for the word Firewall. And then I'll click on Firewall. And then I'll click on Create. So I'm going to deploy this to my subscription and to an existing resource group, and I'm going to call this Azure FW East 1. And it's going to go in the Canada Central region, or in this case, perhaps Canada East, which is where I'm actually at. And down below, I can add a new firewall policy if I've got one. Now, I don't have any existing firewall policy, so I'm going to have to click Add New. I'm going to call this Policy 1, and again, I'll specify a region for the policy resource, Canada East, and I'll choose Yes. Now, we can either deploy the Azure Firewall solution into an existing VNet, or we can create a new one for it. So I'm going to create a new one, and I'm going to call this Azure FW for Firewall VNet. And it's got an address space that it will allocate, so I'm going to go ahead and specify, let's say something a little bit different, 12.0.0.0/16. It's going to create a subnet within that VNet called Azure Firewall Subnet. So if you are going to use an existing VNet, you have to create a subnet with that name, Azure Firewall Subnet, no spaces. So the subnet address space here, let's say we'll put in as 12.0.0.0/24. The Azure Firewall needs a public IP address, so if we have a public IP address resource, then we can select it, but we've got a couple that are already being consumed by virtual machines. So I'm going to have to click Add New, and I'm going to call this Azure FW Pub IP, and I'll click OK. All right, so there we go. I'm going to go ahead and click Next for tags. I'm not going to add any tagging information for the Azure Firewall. I'll click Next, Review and Create. It's going to go ahead and double check my settings to make sure they're valid, after which the validation will pass, and I can deploy the firewall by clicking Create in the bottom left. Okay, so before too long, the firewall will have been deployed. So I'll click the Go to Resource button so we can continue configuring the Azure Firewall. I'll click on Firewall Manager over on the left, and at the top I have a message, Visit Azure Firewall Manager to configure and manage this firewall. So I'm going to go ahead and click on that link. That takes me into the Azure Firewall Manager resource configuration, where on the left I can click Azure Firewall Policies. Now, when we created this, we specified a policy with the name of Policy 1, but we can go ahead and create additional firewall policies. Let's go into Policy 1. So I'll click directly on the name to open it up. On the left, I can configure DNAT rules. Now, DNAT rules allow me to configure connections, essentially public IP addresses and ports, kind of like a reverse proxy, so that we can allow client connections from the internet into services offered behind the Azure Firewall while protecting the true private IP address configuration of those hosts. We can configure network rules, which are standard packet filtering rules based on things like source and destination IP addresses and port numbers, and application rules, where we can configure, for example, restrictions to block outbound access to certain DNS domain names. So I'm going to go ahead and click Add a Rule Collection, and I'm going to call this rule collection Block Social Media. So it's going to be an application rule collection type. The priority here, let's say, will be 100. So if I have a rule here with a priority of 100 versus another rule collection with a priority of 200, this rule set would be checked first because 100 has a higher priority than 200. And if there's a match, then no further rule processing will occur, similar to what you get in a network security group in the cloud. Okay, so I can either allow or deny. I'm going to choose deny. And down below, I'm going to call this block Facebook, and we'll create a configuration for that. So the source IP, let's say, is any IP. I'll use an asterisk as a wildcard. The protocol will be HTTPS://443, so port 443, and the FQDN, or the fully qualified domain name, will be asterisk, again, that's a wildcard, .facebook.com. So anything in facebook.com we are going to block or deny in this particular case. So I'm going to click Add that rule collection. And so our block social media rule collection is shown with the rule called block Facebook. Notice the entire collection is to deny. So if I want to allow something, and in this case, let's say we're going to allow Twitter, then I'm going to have to add not a rule, because the rule collection overall is set to deny, but rather a new rule collection. This one I'll call allowed social media, and it's going to be allow. Here I can specify that I want this to be in the default application rule collection group. Name, let's say for the specific rule, will be allow Twitter, and it's going to be from any IP. Protocol is going to be HTTPS. So we'll leave that in there. I could also specify port 443 after the colon, and the FQDN will be asterisk.twitter.com. That's how we're going to create this. Kind of like how we created the one for Facebook, asterisk.twitter.com, and then I'll click Add, and then I'll add the priority value of 200 for this rule, and I will click Add. Now, both of our rule collections will be shown. The first one has a priority of 100, so it gets checked before the rule collection that has a priority of 200. But let's go back into our firewall manager, and we want to make sure under virtual networks that if it's not already been done, that we associate this with a VNet. So what I've done here is I have associated this with my VNets that are available in my Azure subscription, specifically VNet 1, because my virtual machine, my Windows VM, is deployed there, and I want it to use these firewall rule settings. Now we'll see how to configure routing and how to actually test all of this out a little bit later in a different demo. In this demonstration, we'll be configuring the required network settings in order to make the Azure firewall work. Let's just double check that the firewall was deployed. So here in the Azure portal, I'm going to go to the All Resources view. We've deployed a firewall called Azure FW for Firewall East 1. I'll click to open that up. Now, one of the first things I want to do is check to see, by clicking Firewall Manager on the right and then the Visit Firewall Manager link at the top, whether or not our firewall is associated with the appropriate VNets, so virtual networks in the cloud. So it looks like it is linked to a VNet called VNet 1, as well as Ubuntu Serve 1 VNet and the Azure Firewall VNet, which is where we deployed the firewall. However, it says no firewall deployed for the other two VNets. Let's think about this. I've got virtual machines deployed within VNet 1, and I want them to use our firewall config. But currently it says no firewall deployed, but we've deployed one in a different VNet. What this is telling me is we're going to need to link those VNets together via peering. Okay, that's going to be important. So let's do that first. I'm going to go back to my All Resources view, and I'm going to go down until I find my VNet, VNet 1, and I'm going to configure the peering from here. So in the left-hand navigator, I'm going to go down under peerings. I've already got a peering from my Windows VNet to my Linux VNet, but not to the firewall VNet where the firewall is deployed. So let's add a peering. This is going to be VNet 1 to FW to firewall, and then down below, the reverse peer connection link name will be firewall to VNet 1, and we want to link VNet 1, which is what we're in the midst of configuring, with our Azure Firewall VNet. So I'm just going to go ahead and click Add to add that peering connection. Now remember that when you peer VNets together, that you can connect to resources like virtual machines using just private IP addresses, which is great because we're going to need to be able to do that in the end. Okay, we've got a peered connection that's set up. Let's go back to our Azure Firewall. And remember how we checked the virtual network association, but it said there was no firewall deployed? Let's go back and check all that work now that we've set up the peering connection. So I'm going to go back to the same place we were into the Firewall Manager Virtual Networks. And this time for VNet 1, it says peered to a virtual network with the firewall. Excellent. So that's a good first step. Now, the other thing we have to think about is that for virtual machines deployed within VNet 1, when they are going out to the internet, by default, that is allowed. They'll go straight out directly to the internet. I want to first route outbound traffic to our firewall appliance. So in order to do that, I need to configure some routes, or a route, specifically just one. Let's think about how we're going to do this. Let's go back to our firewall, because in the overview page of the firewall, we will have access to the private IP address. That's going to be important, so 12.0.0.4, and also the firewall public IP. I can click on that to get to the actual IP address itself, which is shown here. Now, this is important because connections from the outside, from the internet, that need to come in through the firewall need to come in through the public IP of the firewall. However, in the opposite direction, which we're talking, our internal virtual machines in the cloud, to force them to be routed through the firewall, we're going to need to make a route that forces traffic to the internal private IP, 12.0.0.4. So I've just clicked to copy that. So what this means is I'm going to go home, I'm going to create a resource, I'm going to create a route table. Just like you might configure a routing table entry on a physical router on premises, the difference here is we're using a GUI and we're doing it in the cloud. So I'm going to go ahead and I'm going to give a name for this thing after we specify the subscription and the resource group. Let's call it route table or RT1. I'll click review and create, and then I'll click create. Okay, so now I'll click go to resource so that we can create a routing table entry. So I'll click routes over on the left, and then I'll click the add button up at the top, and I'm going to call this 2FW for 2 firewall, and 0.0.0.0/0, so that's the default route in IPv4. I want to take all traffic and I want to forward it first to a virtual appliance, and here I'll paste the private IP of our Azure firewall. Now that's great, but we need to associate this route table with a subnet. Specifically, I want to associate with the subnet where I have virtual machines that I want to adhere to these firewall rules. So I'll click subnets over on the left, I'll click associate at the top, and in the list, I'll choose VNet 1, and then I'll go ahead and choose subnet 1 and click OK. So now we've got a route table entry that will ensure outbound traffic from within subnet 1 first goes through our firewall appliance via its private IP address, and we've also linked our VNet via VNet peering to our Azure Firewall VNet so that it knows to use the firewall as well. In this demonstration, we're going to connect to a Windows virtual machine in the cloud to test that it's using the Azure Firewall to block connections to Facebook.com. So you might wonder why Paint is on the screen. It's because I want to diagram some of our work first so that it all makes sense. So let me draw 2 of our VNets that we've got as circles. On the left, VNet 1, and on the right, I'm just going to call this our firewall VNet. Now, what we have to think about is the fact that we have a virtual machine that is running in VNet 1 that we need to connect to. And that virtual machine has a private IP of 10.0.1.4. Okay, well, what's going to happen is we're going to be making a connection from on-premises to the public IP address of the firewall, which in turn then needs to be translated to the IP address, the private IP address of our virtual machine. To do that, in the Azure Firewall, what we're going to need to do is configure a DNAT rule to allow connections from the outside to come into a private IP. So let's go ahead and configure that. Here in the Azure portal, I've opened up my virtual network called VNet 1, and I've already gone down to peerings. I've already got a connected VNet peer link between my VNet 1, and my Azure Firewall VNet. That's important because remember, to contact virtual machines using private IPs in a different VNet, you need to have a VNet peering connection set up. So that's been done. So let's go to our All Resources view at the top here. Let's open up our Azure Firewall to configure the DNAT rule. Our Azure Firewall is called Azure FW Firewall East 1. It's also got its own network security group. And if I open that and take a quick peek, inbound security rules are showing me that port 3389 is allowed from anywhere to any IP address. So that's important because we're going to open an RDP connection to get into our Windows VM to test that Facebook is blocked or not. Okay, so a lot of little moving parts here, but that's the way it goes. A lot of things working together to arrive at some kind of a solution. Let's go back into our firewall because we want that DNAT rule to allow inbound connectivity. I'll go to Firewall Manager and we'll just follow the link there. And I'll go to Azure Firewall Policies. Now, when you want to block, let's say, outbound access to certain URLs, I'll open up the policy. That is called an application rule. We've already configured application rules to allow or deny access to certain fully qualified domain names. So if I were to click application rules over on the left, any of those application rules would be shown. However, if I go to DNAT rules, this is where I need to configure a rule to allow incoming connections. So I'm going to add a rule collection, and this is going to be allow inbound, and it's DNAT, the priority, let's say, is going to be 300. And what I want to do is specify that this is part of the default DNAT rule collection group. The name is allow RDP. And what we want to do is specify the source IP. So from any source IP, protocol is going to be TCP port 3389. That's what Remote Desktop Protocol uses. The destination here is going to be the public IP address of our Azure Firewall. So why don't we go ahead and take a look at where that is exactly. I'll open a new web browser tab and we'll navigate to where we need to be to find out that information. So in the overview page of our firewall, if I click on the link for the Azure Firewall public IP address, here's where I'll see the actual IP. That's what I'm going to copy. So connections are going to be made to the public IP of the firewall from the outside to port 3389, which I want redirected to 10.0.1.4, the private IP address of my Windows server, and that's still listening on port 3389, so I'll go ahead and add that, click the Add button, and our DNAT rule will be showing up in just a moment. Okay, so our allow inbound RDP rule is now ready. So again, the public IP address is what's being used here for connectivity. So I'm going to copy that and let's test an RDP connection from on-premises into the cloud through this firewall. So I've popped in that public IP address in my remote desktop connection client and I'll go ahead and click connect. Now it's going to be good news if it starts asking us questions about do we want to log in or trust certificates and so on. So this is great. It's asking me to authenticate. So I'm going to go ahead and specify the password for that Windows virtual machine deployed in the cloud. And after a moment, it should take us directly into the desktop. Okay, so now in my virtual machine in the cloud, if I try to go to facebook.com, it says it can't reach it over HTTPS, might be temporarily down, might be moved. Of course, it's just being blocked by our firewall. But in another browser window, if I tried to go to something else that wasn't explicitly denied, like google.com, it still says that the action is denied because there's no matching rule, and therefore proceeds with the default action, which is to deny all. Scalability is an important aspect of cloud computing. With autoscaling, we can make a configuration such that when things get busy, such as requests to an application, we can start scaling out horizontally, adding virtual machines to handle the increased workload. And when things quiet down, we can configure scaling in or the removal of VMs. Why pay for virtual machines to be running when you don't need them? So we're going to configure a virtual machine scale set here in Microsoft Azure. So to get started here in the portal, I'm going to click Create a Resource in the upper left, and I'm going to search for Virtual Machine Scale Set. Now, the idea is that we want to have a collection of back-end virtual machines servicing an app. So on the virtual machine scale set page, I'm going to go ahead and click on Create. So the next thing I'll do is just click Create. Next, I'll specify the subscription and resource group for this virtual machine scale set, and I'm going to call it App1 Scale Set. And I'll define this as being running in the Canada East region. Then I'm going to go ahead down below and take a look at the image. Now, all of the virtual machines have to use the same virtual machine image, which presumably would have an app loaded within it. So normally we would refer to a private image here that we've customized or captured, as opposed to a standard marketplace image. I'll choose a Windows virtual machine, We can choose the sizing and then specify the username and password. And then I'll click Next for disks. So from here, we can determine what the operating system disk and any potential data disks that might be added to each virtual machine would look like. So we could create and attach data disks, but I'm not going to do that. I'll go to Next, Networking. We have to define the virtual network where we want to deploy these, so we can use a new one or an existing one. I'll choose an existing virtual network. Then we configure the network interface information for each backend virtual machine in the scale set. That's already been configured, and it's going to be using subnet 2, which was already created in VNet 1. And we could also tell it to use a load balancer if we wanted to, but we won't do that here. I'll click Scaling. Now, in the scaling configuration, we're going to start off at 2 instances, but if I go to Custom, the minimum of 2 is great, but we have to specify what it can grow to. Let's say up to 6 virtual machine instances. What's going to trigger that is when the CPU percentage overall for all existing VMs, once it gets to above 75% for at least 10 minutes, we start increasing the number of virtual machines. We start to horizontally scale out by adding 1 VM at a time. When things quiet down, in this case means 25% CPU utilization. I'm going to keep those, and I'll click Next for management. I'm not going to change anything there. We could also specify some health settings. How do we know that a backend instance is healthy? We could enable health monitoring, such as pointing to port 80 to the root of each backend VM. So if port 80 is not reachable, for example, then the instance is deemed as being unhealthy and will not receive client requests. So I'm just going to continue through here. We're not going to add any additional settings here, so I'll just click Review and Create in the bottom left. And to create the virtual machine scale set after it has run the validation and the validation has passed, I'll just click the Create button in the bottom left. So after a few moments, if I go to the All Resources view, my scale set will show up. And if I click on the scale set to open up its properties, in here I can change some of the configuration or check out the number of backend instances currently running. So if I click on Instances on the left, we've currently got 2 backend virtual machine instances running based on the image we configured. But notice that the health state of both of them is unhealthy. And that's only because we configured a health check for HTTP port 80. And of course, the image I selected does not have a web server listening at all, let alone on port 80. So therefore, they are quite rightly showing up as being unhealthy. But what's interesting about this is that we've got these 2 virtual machine instances running for the scale set. But if I were to take a look at my regular running virtual machines in Azure, the ones for the scale set do not show up here, because the ones in the scale set were created only as a result of the scale set, not manually as infrastructure as a service. And so if I want to start managing those instances, then I have to do it at the virtual machine scale set level. When you're working with cloud computing, you might come to a point where you need a centralized and secured way of storing secrets. The secrets would include things like database connection strings, maybe that software developers will refer to in their code, or working with decryption keys and encryption keys for protecting data at rest, whether it's in a storage account in the cloud, virtual machine hard disks, and also working with PKI certificates. All of these items can be managed centrally in a Microsoft Azure Key Vault. So let's get to it. Let's create one. Here in the Azure portal in the upper left, I'll start by clicking Create a Resource, and I'm going to search for Key Vault. And then after that, I'll click on Key Vault, followed by clicking on Create. So as usual, when I build something in the Microsoft Azure cloud, I'll have to tie it to a subscription and also deploy it into a resource group. So I'll use an existing resource group. The Key Vault name, let's say, will be KV172 East. And I'm going to deploy this, let's say, in the Canada East region, only because that's where it will be accessed most frequently. And by default, it's set to retain deleted vaults for 90 days for safekeeping before it's permanently purged. That's fine, I can accept that. But the next consideration is who or what, in terms of software, will have access to the secrets in the vault. That's called an access policy. And so let's go down and click Next, Access Policy. So I can determine, for example, that disk encryption is enabled, which would allow virtual machines to be able to come in and find an encryption key I choose when I configure disk encryption for VMs. But the Vault Access Policy automatically includes who I'm currently logged in as, a user called ITDemo1. And for keys, these are decryption keys. We have all permissions. For secrets, which would include things like database connection strings, all permissions. Same goes for PKI certificate permissions. Now, of course, we could click Add Access Policy, and we could select other users or groups and determine which of those 3 sets of permissions are applicable. But I'm okay with what we have here for now. So having done that, I'll click Next for networking. So from which other networks should this key vault be accessible? The default is public, all networks, but we could choose selected networks where we can add an existing virtual network. So let's say, for example, I want to restrict it so that only virtual machines or software code that's running somewhere within VNet 1 is allowed to talk to this key vault. So I'll choose VNet 1, and from here I could even specify the subnet. So once I've done that, I would just click Enable. So I'm limiting or restricting access to this key vault from certain networks. So I'll click Next for tags. I'm not going to add any tagging information. So Next, Review, and Create. And once the validation has passed based on my selections, I'll create the key vault by clicking Create in the bottom left. Okay, so now I'll click Go to Resource. And what we're going to do here is, let's say, generate a key. So if I go to keys, any existing keys in the key vault will be listed, but of course there will be none because we've just created this key vault. So I'll choose Generate Import up at the top. Now I don't have any existing keys to import, so instead I can choose to generate keys. I'm going to call this key 1. It's going to be an RSA key, let's say 2048. And the great thing about this too is I can set when the key becomes active and when it expires. So I'm not going to put those values in, so it's always valid. And I'll click Create. Now I get a message at the bottom that says, well, love to do this for you, except I can't because the firewall for the key vault is turned on and your client IP address is not authorized. Oh, okay, so what do I do to fix that? Not a problem. Let's close out of this. We'll have to come back and do this again, but it's not the end of the world. What I want to do is configure the security for this particular key vault. So I'm going to go ahead and click Networking over on the left. Now the firewall is shown down here below. However, what I want to do is make sure that our client IP is allowed to access this key vault. So I've pasted in my public IP as it's known from the network I'm working from. Now, the only reason that we're blocked out is because, remember, we restricted network access to VNet 1, subnet 1. But that's okay. We've fixed this. So let's go ahead and click Save to save that firewall configuration. Then we're going to go ahead and we're going to try to create an encryption key again. So for that, let's go back to keys on the left and let's do what we did before. Generate import key 1, and we'll click Create. And this time it will accept this administrative activity because our client IP is added to the firewall. So key 1 now shows up. We could also create a secret. I could choose Generate Import. And normally this would be used, for instance, for a database connection string. So let's say DB1 string. And then we could enter in whatever the string value is. We could set an activation and expiration date, and we could choose Create. And then that will be stored here so it can be referred to instead of writing that kind of thing into code. And finally, we can also generate PKI certificates that we might want to use, let's say, for HTTPS website bindings. So I'll click Generate Import. Again, I'm not going to import, I'm just going to generate, and maybe this will be called Website 1. It's a self-signed certificate where the common name would be www.website1.let's-say.com. Configure the DNS name for it, which is normally the same, www.website1.com. I'll just click OK, and I'll accept the default for the details down below, and I'll click Create. So we've created each of the 3 types of secrets that are available centrally in this cloud-based key vault. Encrypting data at rest is really these days required by most data privacy standards. So to enable this in the Azure cloud, I'm going to begin by creating a storage account. Then I'm going to use a custom encryption key to protect data at rest, to encrypt the contents of the storage account. So to get started here in the Azure portal, I'm going to click Create a Resource in the upper left. And what I want to create is a storage account in the cloud. So I'll search for storage account. And when it pops up in the list, I'll then select it. And then I'll click on Create. So I'm going to deploy this into a specific resource group, and I'm going to call this store account east 172 or 182 in this case. I'm going to specify the region where I want that deployed. And really, I'm just going to accept a lot of the defaults here, including allowing access from any networks, if that's the purpose of this, if we should allow anonymous access, or it could be selected endpoints. So I could select that and specify VNets and so on. However, here I'll leave it on public. Next, for data protection, we can turn on things like point-in-time restore, soft delete, so that we have items that were deleted that are available for a period of time before they're permanently removed. So for example, for 7 days. So I'm going to go ahead and continue on through this wizard. And basically, I'm going to go to review and create to the point where after it passes the validation, we will click create to create this storage account. So now that it's deployed, I'll click the Go to Resource button to open up the properties of our storage account. And over on the left, what I'm really interested in is going down to encryption. On the right, currently, Microsoft managed keys are being used to protect data at rest in this storage account. And that might be fine, but in some cases, maybe even for regulatory compliance, you might need to control encryption keys, in which case you could choose customer managed keys. And down below, I could select from a key vault. So I'll click the key vault link. And from here, I'm going to choose the key vault from a list. And within the key vault, of course, I could choose the encryption key. Now, I've already created a key vault and a key, so I'm just selecting what I've created previously. So I'll just go ahead and choose select and save. So in this way, we've got not only protection through data at rest, encryption, but we have complete control of the encryption key that was used to do that.